Hey super learners, welcome back to Master and Learn It, where learning is fun and facts stick like glue. Today we're cracking the code of numbers using prime factorization. What are prime numbers? And how can we break down real big numbers into their prime pieces? Let's get right in. So before we can start by defining what is a prime number, let's start by defining what a factor of a number is. So a factor of a number is that number that can fit inside a number without leaving a remainder. So by definition, here's our definition. A factor of a number divides that number without leaving a remainder. For example, factors of 4 are 1, 2, and 4 itself. Factors of 12 1, 2, 3, 4, 6, and 12 itself. These are factors. These are numbers that can fit inside a number without leaving a remainder. So we can group numbers into two groups: numbers that can have more than two factors and numbers that have only two factors. So let's check this one out. We have a number that we call composite numbers. So composite numbers have more than two factors. For example, 4 is a composite number, 6 is a composite number, 12 is a composite number because they have many factors. 100 is a composite number. You can name all the numbers that you know that have more than two factors. Then we have certain special numbers that we call prime numbers. I'm going to just write them here, prime numbers. So what are prime numbers? This is where our lesson is based on. Our prime numbers are numbers that have only two factors, 1 and that number. For example, factors of 2 is just 1 and 2. Factors of 3 is 1 and 3. Factors of 5 is 1 and 5. Factors of 7 is 1 and 7. Factors of 11 is 1 and 11. These are what we call prime numbers. A number that has only two factors, 1 and that number. That's what we call prime numbers. And the numbers that have more than one factor, we call them composite numbers. So we can express any composite number using prime numbers. How is that possible? So this is the essence of prime factorization. So prime factorization is to express any number that has more factors, any big number with many factors, which we call composite numbers, into their prime factors. In other words, to express it using prime numbers. Here is a list of all the prime numbers basically that we're going to be using, not all of them. One is not a prime number, so I'm listing a few prime numbers that we're going to have to make use of. So let me just list the prime numbers that we're going to be using. Prime numbers. So we have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 43, as it goes. So these are basically the prime numbers. So we can break down any big number according to its prime factors. So let's get just right in. Let's say I give you a big composite number called 100. How can you write 100 in using prime numbers? So we're going to divide the composite number by the smallest prime numbers that we have. So my smallest prime number 2 can divide 100. 2 into 100, we know 2 into 10, that's 5, into 0, that's 0. So that's 50. We divide again by the smallest prime number, which is 2. 2 into 50, that's 25. We can divide again 25 by the smallest prime number. 3 cannot, 2 cannot, 5 can. 5 into 25, that's 5. And the smallest prime number to divide this 5 is 5. 5 into 5, that's 1. So we can express 100, a composite number, as a product of its prime numbers, which is 2 times 2 times 5 times 5. 2 times 2 times 5 times 5. So this method is what we call the ladder method. So that's the first method we can use, using the ladder method. How about if I say express 42 using the ladder method? This is a composite number as a product of its prime factors. So I'm going to divide by the smallest prime number, 2, 2 into 4, that's 2, 2 into 2, that's 1. Smallest prime number to divide 21 is 3. 3 into 21, that's 7. Smallest prime number to divide 7 is 7. 7 divided by 7, that's 1. So 42 can be written as 2 times 3 times 7. So this is how we express any composite number as a product of its prime numbers, because all these are prime numbers. We can use the ladder method, and we can use what we call a factor tree method. So I'm going to show you also how you can either use a ladder method or a factor tree method. So if I were to use the factor tree method to find factors of 42, you start by writing your 42, you break it down. The smallest prime number to divide 42, that's 2. 2 into 42, that's 21. 21 is a composite number. We can split it by starting with the smallest prime number that can divide 21, which is 3. 3 into 21, that's 7. And now 7 is normal a composite number, so that's now a prime number. So 42 can be expressed as 2 times another prime number 3 times another prime number 7. I hope you find this video to be really interesting and really beneficial. If you really did, please don't forget to give it a big thumbs, and always subscribe to Master and Learn It, where we find maths numbers to be simple and enjoyable. And in the next video, we're going to learn about how we can use the prime factorization to find the highest common factor and the lowest common multiple. Watch the next video.